see I've actually got, let's set it to random and let's press play and see what happens. And there you go. You can see we've pretty much got a free-for-all. Our particles are just basically going wherever they fancy. They set up a random target as they enter the event, and they go over and they try and hit that target. Now, the next option is closest pivot, and that probably will make perfect sense straight off. What it'll do, it'll actually analyze all the targets, find the target with the nearest pivot point to the particle, and then it will actually head towards that pivot point. Now, if I press play, let me set it to closest pivot and press play, and we can actually see that in action. So there you go. As you can see, the particles on the left-hand side of our source are heading towards the nearest pivot to them, and you can see the rest of the particles are obviously heading off towards the object which is nearest to them as well. Now, if I make this source a little bit bigger, you can actually see at some point the particles are going to find different pivots to actually head towards. There you go. Just put it back down to where it was before. There we go. I think that's pretty good. So that's the closest pivot option. The next option is closest surface. Again, pretty intuitive, I think. In this case, it's actually not going to look for the nearest pivot to it. It's actually going to look for the nearest surface to any particle. When it finds that surface, it's going to try and go and hit that surface. So in this case, there's actually not really that much difference, to be honest. As it turns out, because these surfaces are actually quite close, it's not going to make that much of a difference. So let's have a look at the next option, which is the least deviation. There we go. And what this does is it will actually calculate a trajectory from the current traveling direction of the particle to each of the targets, and it'll work out which one of them would be the one it would actually have to deviate the least on its course to reach, and whichever one it has to deviate the least, it'll actually go and try and hit that target. So as you can see in this case, it's actually causing our particles to arc, as you can see here, and they're heading towards these different targets. That's pretty cool. Now, the last one is special in that it's using scripting, and it's not something in the fundamental series we'll actually be covering a great deal of. We've had a look at the script operator in one of the other DVDs, but to be honest, it's not the sort of thing that you're really going to learn at the fundamental level, unless of course obviously you're already well versed in scripting. But I'm not actually going to skip on that. I'll actually show you how that works. I'm going to say by script integer. And if you actually look in this event here, you can see I've got some script operators actually set up already. And you can see one of them is called integer successive. So if you know scripting, you can actually go in there and have a look at this. And this example is included with this DVD, so please be my guest and actually go in there and have a look at this. It's a very simple script. And basically what it's doing is it's looking at the time and it's dividing it by 160 here, adding on 1 and divided by 15. You've got this little sort of calculation going on here. And what that does is it basically works out a number, and based on that number it sets the target integer to either 0, 1, 2, 3, 4 and 5. And if it's none of these particular values, then it actually just sets it to the default, which is 0. Now these meshes actually have these index numbers assigned to them, and they're actually assigned those numbers based on how they were actually added to the test. So what actually happens is, as time progresses, it changes the index value that the particles are actually trying to get to. At first it sets it to 0, then it sets it to 1, then it sets it to 2, then to 3, 4, 5 and so on. So if I press play, there you go, you can see they go to 0, then 1, then 2, then 3, then whatever. So 0, 1, 2, 3, 4, 5. So that's pretty cool. That means that if you want to, you can actually set up a script in your flow, and you can actually define exactly which target you want the particles to go to. If you don't want to rely on the nearest pivot point or the nearest surface or the least deviation or any of those things, if you want absolute control, you can create a script and you can actually define exactly which target the particles are going to go to. You can make that conditional on a number of things. You could base it on the speed of the particle, or you could base it on the proximity of the particle to the target, or you could base it on the scale of the particle, or you could base